The intermediate value theorem. This is one of those theorems that seems so straightforward. So it's like, why do we even go over it? But at the same time, it is very important to mathematics and has some other results and things. So we're going to go through this. This does pop up every now and then on the AP test. So it's not a waste of time. The idea of the intermediate value theorem is that if a function's continuous on an interval, and let's just say you have an f of a and an f of b, then somewhere within that interval, it's going to equal some value in between. So what do I mean by that? So let's just do an example. If you have that f of 1 equals 5 and f of 4 equals 10, then that means somewhere in the interval between 1 and 4, so somewhere within this interval, our function at some value of x is going to have to equal, let's just pick a value between 5 and 10, like 7. Somewhere in between there, it's going to equal 7. So let's think about this graph. If f of 1 was 5, f of 4 was 10, as long as our function's continuous, it can do whatever you want it to do. It could be crazy. Well, it's got to be a function that's no longer a function because this little loop there. But, you know, it could do some crazy stuff, but somewhere in that interval, it's got to equal the value of 7 because this is 5, this is 10, so it's got to equal 7. So let's just say this is 5, this is 10. So somewhere in there, let's just say this right here would be 7. Well, somewhere, and it could happen more than once, but at least one time, it's got to equal that value of 7 somewhere in there. And it could just go straight up like this. Boom, right here it equals 7, but at some point it's got to equal 7. Now, how is that guaranteed? Well, what if there's a jump discontinuity? Well, then it doesn't equal 7 any point in there. But remember, the requirement in order to have the intermediate value theorem work is that it has to be a continuous function. It's kind of funny because there's all these words, and really the continuous function is kind of the most important part because if it's not continuous, it's going to fail. Or not necessarily fail, but there's a chance it could fail. So the only way it's guaranteed is if it's a continuous function, then somewhere in between from that interval from 1 to 4, somewhere in between in this interval, it's going to have to equal 7 if it's continuous. Meaning if I draw from each endpoint without lifting my pencil, it can do whatever I want. I just can't lift the pencil. It's going to equal 7 at least once in there. And like I said, I know there's some applications of this. I can't think off the top of my head. I don't know if you necessarily understand them yet, but there are quite a bit of applications from this theorem. So it seems surprisingly simple, but it is very important in mathematics. So let's look at an example. Let f be a continuous function on the closed interval from -2 to 1, where f of -2 is 3 and f of 1 is 6. So think of those numbers, 3 and 6. So we know for sure that f of x from that interval, if you were to draw it, from -2 to 1, is going to have values between 3 and 6. We don't know. There could be -10. -10's down here. There could be. We don't know for sure. We just know for sure all the values from 3 to 6 will be taken up. So if I look at this, f of c equals 0. No, because it's got to be between 3 and 6. That's the only thing that's guaranteed. 0, no. What about 4? Yeah, it could equal 4. 4 is between 3 and 6. So, and the interval, though, is from -2 to 1. So we know that it's going to equal 4 somewhere on that interval from -2 to 1. So we're going to check off this one. That's the idea here. If you look at this one real quick, our interval's from -5 to 0. To be consistent, I should use green from -5 to 0. So we're looking at our intervals. We're going from -5 to 0. And notice the output values, 0 and 5. So we have to pick a value that's between 0 and 5. -2 is not between 0 and 5, but 2 is between 0 and 5. And it's talking about the interval from -5 to 0. So f of c is going to equal 2 for at least one value between -5 and 0. Okay, for a table, which intervals must contain the solution g of x equals 3? So if we look at these intervals And this is an important part. We need to let g of x be a continuous function. So we're assuming that the table, you have to check with the table that it is a continuous function. So if it's a continuous function, so it is, we can use that intermediate value theorem. So from -1 to 2, if I look at -1 to 2, from -1 to 2, then I know the outputs are going from 0 to 4, so 3 is in between there. So that checks off. That's good. What about from 2 to 4? That's going from 4 to 9. It could equal 3, meaning, it starts at 4. It could dip down to 3 and go to 9, but we don't know for sure. We just know for sure that it's going to equal the values between 4 and 9, and 3 is not between 4 and 9. So we can't guarantee that that's going to happen. And then last, from 4 to 5, it's going from 9 to 15. That's going to be a low dip, which is possible, but not necessary. So, the only one we know for sure is that from -1 to 2, it's going to equal 3, because it has to go from 0 to 4, so it has to cross 3 at some point. And that's the idea of this assignment.